Have you ever wondered why calculus is such a crucial part of our lives, even if it doesn't seem so on the surface? Well, let's take a moment to demystify this. Calculus, a branch of mathematics that revolves around rates of change and accumulation of quantities, is more relevant to our daily lives than we often realize. In the realm of science, calculus plays a pivotal role. For instance, in physics, it's used to describe the motion of planets, the propagation of light, or even the behavior of quantum particles. In the field of engineering, it's an integral part of designing structures, predicting how materials will behave under certain conditions, and optimizing processes for efficiency. But calculus isn't limited to just science and engineering. It also has a significant role in economics, helping economists to model and predict economic behavior. For example, calculus can help economists understand how changes in interest rates can impact the economy, or how supply and demand curves interact to determine prices. In the environmental science domain, calculus enables scientists to model ecosystems, predict changes in climate patterns, and understand the spread of diseases. It's a powerful tool for understanding and predicting the natural world around us. But it's not just about these specific applications. The beauty of calculus lies in its ability to help us make sense of complex situations. It allows us to break down complicated problems into simpler, more manageable pieces. This ability to analyze and solve complex problems is a skill that's widely applicable, not just in the aforementioned fields, but in everyday life as well. Whether it's figuring out the fastest route to your destination, deciding on the best time to buy or sell stocks, or even understanding how a virus spreads in a population, the principles of calculus help us navigate these complexities. And that's just scratching the surface of the relevance of calculus. Its principles and methodologies permeate so many aspects of our lives, often without us even realizing it. So while you may not be crunching calculus equations daily, the concepts and principles it embodies are all around us. Dive into the world of differential calculus, one of the two main branches of calculus that focuses on how quantities change instantaneously. Let's unravel the concept of differential calculus. At the heart of differential calculus lies the concept of derivatives. A derivative could be seen as a mathematical detective revealing the rate of change of a function at a specific point. It's the mathematical equivalent of a speedometer in a car, giving you the instantaneous velocity. Imagine you're on a road trip driving along a winding highway. Your position changes over time, and so does your speed. If you plot your position over time on a graph, the function would describe your journey. Now, if you wanted to know your speed at a specific point in time, you would use the derivative of that function. The derivative at a particular point on the function is like a snapshot of your speed at that moment. This concept is not just confined to the realm of abstract mathematics, it's grounded in real-world applications. Consider a manufacturing process in a factory. The production rate changes over time due to various factors such as supply availability, machine efficiency, and labor productivity. By using differential calculus, the factory can optimize its processes. The derivative of the production function reveals the rate of change of production at any given moment. This information can be used to make vital decisions, like when to ramp up production or when to maintain it. Differential calculus also plays a pivotal role in understanding the dynamics of motion in physics, the fluctuations in economic models, and even the growth patterns in biology. In the grand scheme of things, differential calculus is like a powerful microscope, allowing us to zoom in on a specific moment and analyze the rate of change. It gives us the tools to dissect dynamic situations, unravel complexities, and make informed decisions. In essence, differential calculus gives us the tools to analyze dynamic situations with precision. Now let's explore integral calculus, the other main branch of calculus that deals with accumulated quantities and areas under curves. At the heart of integral calculus is the concept of the integral. Simply put, an integral is a mathematical tool used to compute accumulated quantities. Think of it as the mathematical equivalent of adding up a series of small quantities to get a total amount. Let's bring this to life with a real-world example. Imagine a tank being filled with water. The rate of water flow into the tank changes over time. Maybe it's fast in the beginning, slows down in the middle, and then picks up pace again towards the end. This rate of flow can be represented by a function. Now, if you wanted to find out the total volume of water that has flowed into the tank over a specific period, you would use an integral. By integrating the function representing the rate of water flow, you calculate the total volume of water accumulated in the tank over that period. But the power of integral calculus extends beyond just calculating volumes. It also allows us to find the area under curves. This is incredibly useful in a variety of fields. In physics, for instance, it can be used to calculate the work done by a variable force. In economics, it helps in finding the total cost from the cost function or the total revenue from the revenue function. The real beauty of integral calculus lies in its ability to deal with complex, changeable situations. It allows us to break down problems into infinitely small parts, analyze them, and then add them all up to find a solution. It's a bit like solving a jigsaw puzzle by carefully putting together each tiny piece until you see the whole picture. Therefore, integral calculus provides a method for analyzing quantities such as area, volume, and mass distribution. It's a powerful tool that empowers us to navigate the complexities of our dynamic world. Together, differential and integral calculus form a powerful toolkit for problem solving. These two branches of calculus may seem very different at first glance, but they are in fact two sides of the same coin, working in tandem to tackle a wide spectrum of problems. Think of them as two parts of a symphony. Differential calculus is like the staccato notes dealing with the instantaneous, the here and now. Each note represents a moment in time, a snapshot, if you will. It's about the immediate rate of change, the velocity of an object at a specific point, the marginal cost in economics at a particular level of output. Integral calculus, on the other hand, is like the legato notes, smoothly connecting the dots over a period of time. It's about accumulation, the total change over an interval. It gives us the total distance traveled by an object, the total cost of producing a certain number of goods. But just like in a symphony, the magic happens when these two parts come together. The harmony of differential and integral calculus allows us to understand the world in a more comprehensive way. From modeling the growth of populations in biology to optimizing production in economics, from designing efficient structures in engineering to predicting the behavior of particles in physics, calculus provides a unified framework for analyzing dynamic systems. It's this synergy that makes calculus such a versatile tool. It's not confined to the realm of mathematics. It permeates various fields, helping us to make sense of complex phenomena and solve real-world problems. And it's not just about solving problems, it's about understanding the underlying principles, the fundamental truths. It's about developing a way of thinking that goes beyond numbers and equations. It's about making connections, seeing patterns, and uncovering the beauty and complexity. So, when we speak about calculus, we're not just talking about a branch of mathematics. We're talking about a way of perceiving the world, a lens through which we can explore, analyze, and understand. Thus, calculus is more than just a subject. It's a mindset that empowers us to analyze problems and make informed decisions. Beyond its practical applications, calculus also fosters critical thinking skills. As we delve deeper into the world of calculus, it's clear that this branch of mathematics isn't just about crunching numbers or solving equations. It's about understanding abstract concepts and applying them in a practical context to solve real-world problems. Calculus challenges the mind to grapple with concepts that may initially seem abstract and elusive. For instance, the idea of an instantaneous rate of change or the total accumulation of quantities over an interval can be perplexing. But as students wrestle with these ideas, they begin to see the world differently. They start to grasp how changing circumstances can have profound impacts and how accumulations over time can lead to significant results. Moreover, calculus promotes a culture of experimentation and exploration. It encourages students to take risks, make educated guesses, and learn from their mistakes. For example, the process of finding a derivative or an integral often involves trial and error, testing different approaches until the correct solution is found. This process not only sharpens problem-solving skills but also cultivates resilience and perseverance. Additionally, calculus demands precision and attention to detail. Whether it's applying the chain rule in differential calculus or evaluating a definite integral, every step matters. One small error can lead to a completely different result. This necessity for accuracy enhances focus, diligence, and the ability to spot and rectify mistakes. In essence, calculus stretches the mind in new and challenging ways. It pushes students to think critically, reason logically, and solve problems creatively. It's not just about learning formulas or techniques, it's about developing a deeper understanding of how the world works and using that knowledge to make informed decisions. By embarking on a journey through calculus, you unlock a world of endless possibilities and pave the way for future discoveries and innovations. Whether you're a budding scientist, an aspiring engineer, or a curious thinker, calculus equips you with the tools to explore, innovate, and make meaningful contributions